Okay, I'm going to talk about logarithms here. So let's just begin with. So logarithm is denoted by log. Okay, uh, we write a number. Let's write a number n. Basically, logarithm is also a number, but it is a function. You know, we write logarithm as log x base a. So this is right here. This is base of the logarithm. This is known as argument of the logarithm. This is right this part in this parenthesis. Sorry, this parenthesis. In this parenthesis, this part is known as argument. This part is known as base of the logarithm function. So we talked about that how to denote logarithm. Let's talk about its functionality. So basically, if logarithm tells it how much power should we raise a number, so to a number. So yes, I'm going to explain you with example. So let's take log base 10 and in argument let's take 100. So how much power should we raise to 10 to get 100? How much power should we raise of 10 to get 100? So we need to raise 2 power of 10 to 100 to get 100. Now we can simply write that like log 10 square. Okay. Uh, 10 into 10 is 100. Okay, unit. So how much power should we raise? We raise 2 power, 2 of this base, uh, of this base in the argument. We raised 2 power of the base in the argument. So the answer of the logarithm is 2. So similarly, like that, if I take another example, like log, let's take 16 and let's take base 2. So, mm, so 2 power 4 is 16. So how much power should we raise it? We raised the 4 power of the base in the argument. So the answer should be 4. So yeah, logarithms works like that. So if we talk generally, if we talk in general terms, let's take an example here. Log 2 square base 2. Okay, this is for example purpose. Let's take a general term. Okay, let's take log a power m. Okay, base, I'm taking base as n. Okay, so how should we simplify this? So we are saying that this answer is coming is 2. The raised power is 2. So 2. So we can write 2 as 2 into 1, 2 times 1. So 1 is what? We can write 1 as log 2 base 2, like that, because here we have 2 raised to power 1. So log base 2, and in argument the power is raised 1. So this will have to be 1. So I wrote 1 as this. So what is this? Uh, this is this thing. this thing right here. So what happened here is the power came in front of this expression. We can see that simply. So we can write this as, so we can here do the same. We can take the power in front of this, multiply this, and write this as log a base n. So this is a property of logarithm. Yeah, the power property. The power comes in multiplication of logarithm. So if I take an example, let's take an example. Log 1000 base 2. So I can simplify this as, mm, I can write 1000 as 10 cube base 2, and I can write this 3 in front of this logarithm, log 3 base 2. Yeah, I can simplify this logarithm term like this. Okay, the first simplification steps. Okay? Let's solve some complex problem on this property, and after that we can, yeah, I'm going to tell you something first, and then after we can solve the problems. Okay? So what happens if I add log 10 base 10 plus log 10 base 10? So if we ignore the fact that this is power 1 and this is power 1, they both become 1 and 1, 1 plus 1 2. I'm writing it as 2 times uh, log 10 base 10. Okay? I am first writing it as like this. And I am writing a general thing also here. This is power 1. I feel that. Okay. I am writing a general thing like log m base a, and I'm adding. So bases should be same. Okay. Uh, I'm adding log n base a, for example. So yeah. So what happened here? Uh, by the previous property, we can write this 2 in the power of this 10. Okay. So let's write it. Log 10 squared. Okay, sorry. Log 10 square base 10. What happened here? Uh, if you see like this, uh, basically the 10, this 10 and this 10 have multiplied. These two powers have added. Uh, you can see that the base is still the same, the base is still 10, and these two numbers have multiplied. So 10 is basically this 10 and this 10 multiplication. So here comes a property, uh, here comes a second property, that if the bases are same and we are adding logarithms of different arguments, then they will multiply with the same base. The answer will be their multiplication. M times n. Okay. So this is the answer for this particular expression. So this is a property of logarithm. We need to remember. Okay. Similarly, let's take difference. We talked about some. Let's talk about difference. Log n minus log n basically. So I can write log n this as plus minus log n base a. Can I write that? Minus is minus 1 into this expression, and this looks like property number 1. I have told you that this this number can go to this power, this power. So let's do that in the next step. So I'm writing m base a plus log of n to the minus 1 power. Okay, n power minus 1 base a. So now this has become like property number 2, some property. So this 2 should be multiplied. The arguments must be multiplied. Okay, the arguments. Let's multiply the arguments to give the final answer. Is a m into 1 by n. Okay, n to the minus 1 is 1 by n. So yeah, this has become log m over n. Yeah. So this is a property. Log m plus log n is equal to log m into n. Log m minus log n is equal to log m in m by n. Sorry. Here this new page is added. Sorry. Yeah. This is a property, and this is also property, and this is also a property of logarithms. Okay. So let's let's do some problems. Let me clear this. Yeah, cleared. Now let's do problems. Okay. Let's say I'm taking log 1000 base 10 and I'm subtracting log 625. Okay. 625 base 25. Let's simplify that. Basically, log 1000 is log 10 cube. This is base 10. Okay. Simplified. And minus log 625 is 25 squared. 25 squared, this is 25. And if we use the property number 1, or we can say that the power raised of the base in the argument is 3. So answer will be 3 minus, we put minus as it is. So power raised in the base, uh, power raised of base in the argument is 2 here. So this becomes 2, 3 minus 2 is 1. So this is the answer for this particular expression. So let's try another problem. Second number problem, second one. Log 225 base 50 minus log 625 base 5 base 15. Okay, let's solve this. So as we can see that it is like a difference property. The bases are same. No? When the bases are same, then this property becomes property number three. So it will be the ratio of this by this. So I'm going to write it. Base is as it is same. Numerator comes 22, 25. Denominator comes 625. Okay, I'm cancelling with this 5. Uh, 5 fours 20, 2 5 5 25. And here 5 ones, 5 twos, 5 fives. 1 2 5. Let's cancel one more time with the 5. 5 nines 45 and 5 ones 5 fives. Okay, so this will be simplified as log 9 over 15 base 15. Now what we can do is, yeah, leave it that way. Leave this like that. Yeah, that's it for this video. Okay.